All right, let's jump right in. We're about to explore a really powerful way of thinking that connects two worlds you'd never expect to see together. One of the most successful and secretive hedge funds in history, and the super technical design of a brand new language for AI. The thing that links them? A genius way of taming chaos. So that's a quote from James Simons. He's a legendary mathematician who founded a hedge fund called Renaissance Technologies, which has been so ridiculously successful it almost seems fake. So why on earth would he say he doesn't want people with finance experience? I mean, that sounds completely backward, right? Well, to get to the bottom of this, we've got to look at the company's core philosophy. It wasn't built on what you'd call financial wizardry. Nope, it was built on something way more fundamental. See, their system was the real secret sauce. Instead of hiring Wall Street pros, they brought in pure scientists, physicists, mathematicians, statisticians, and basically locked them in a room together. The whole philosophy was to stick to the math, use airtight logic from the ground up to find the real signals hidden in all the noise of the market. And get this, they didn't chase a bunch of different strategies. They just kept improving one single monstrously complex model, year after year after year. Okay, that's a fair question. Stick with me here. We've been talking about billions of dollars and complex financial markets, but now we're going to pivot to a totally different kind of chaos. The messy, unpredictable, and often frustrating world of human language. So let's see how this exact same way of thinking shows up somewhere else entirely. You know, when we talk to an AI, we're just using our everyday language. And it turns out, our language is another one of these incredibly noisy systems, just packed with chaos. Just think about it for a second. If you tell a friend, go to the bank, they know exactly what you mean from context. But for a computer, that's a huge point of failure. Is it supposed to call an Uber to take you to Wells Fargo, or should it plot a walking route to the nearest river? That ambiguity is a massive, massive problem. So here's the radical solution that was proposed. Instead of just trying to make the AI get better at guessing, you invent a whole new language called explicit prompt that literally forces the human to be, well, explicit. It's built with a really rigid, logical structure that's designed to just strip away all the ambiguity before the AI even gets the command. And this slide just shows the difference perfectly. On the left, that vague prompt, that's a total gamble. But the explicit prompt on the right is a clear, deterministic command. It forces the system to first look up the exact agreed-upon meaning of bank in a shared dictionary, they call it an ontology, and then act. Just like that, the chaos is gone. Now, to get this kind of ruthless efficiency, the people who designed this system didn't use the programming tools you might expect. They went way, way deeper, searching for what they called a bare metal feeling. You know, that sense of total control and raw performance. I absolutely love this analogy from the source material. You know, old school programming was incredibly powerful, but it was also super dangerous. One tiny mistake and you could crash the whole computer. Modern tools are way safer, but they add all these layers between you and the machine. The goal here was to find that perfect middle ground. And this chart shows exactly where they landed, WebAssembly, or WASM. It's not true bare metal, but it sits right in that sweet spot. It's way lower level and faster than something like JavaScript, but, and this is key, it runs inside a secure sandbox, so it can't accidentally break anything. So what's the actual trade-off? Well, you give up that raw, direct-to-the-metal control you got with old-school assembly, but what you gain is huge: safety, the ability to run on basically any device, and automated optimization. It gives you that minimalist, in-control feeling without the danger of, living in the dirt with a shovel. Okay, now this is where it gets really clever. A system that's built on this kind of clarity doesn't just sit there. It can actually learn and evolve over time, getting faster and cheaper the more you use it. This whole thing is possible because of a component they call the explicifier. The best way to think about it is like a security guard for meaning. It says semantic mint. It stands at the gate and refuses to let any vague, fuzzy, or corrupted language into the system. It basically prevents a situation where bad, vague words drive out good, precise words. And here's the magic of how it works. The very first time you give it a vague command, the system has to make a really expensive call to a big AI model in the cloud to figure out what you meant. But once it gets a clear interpretation back, the explicifier mints that answer as a new, perfect word in its local dictionary. So the next time you use that phrase, the system recognizes it instantly, right there on your device, and completely bypasses that slow, costly API call. The result of this symbiosis is, well, it's dramatic. You go from a system that's high cost and super slow because it's always guessing, to a system that's basically zero cost and lightning fast because it just knows. The more you use it, the smarter, faster, and cheaper it gets. It's an incredible feedback loop. So we've looked at this legendary hedge fund, and we've looked at this super niche AI programming language. It's time. Let's finally connect the dots and reveal the single, powerful idea that brings them both together. Here it is. This is the whole point. The philosophy that was used to design this AI language is the exact same philosophy used to build one of the most successful hedge funds in history. These two things, built decades apart to solve totally different problems, they're secretly spiritual twins. They were born from the very same mindset. And this table just lays it all out, side by side. It's almost spooky. Renaissance rejected industry experts for pure scientists. The engine rejects high-level fluff for first principles tech. Renaissance's core job was to separate signal from noise. The engine's is to resolve ambiguity in language. Renaissance sticks to the math. The engine relies on deterministic, unambiguous logic. And finally, they both evolve. Renaissance keeps improving one core model, while the engine grows a shared language with its user. It is the exact same pattern. And this is what we can call the kernel mindset. It's this core belief that the only way to truly master a complex, noisy, chaotic system, doesn't matter if it's the stock market or human language, is to ignore what everyone else is doing, go all the way back to the absolute beginning, and build your entire solution on a tiny, minimalist kernel of determinism and absolutely ruthless clarity. And that really leaves us with one last, fascinating question to chew on. If this mindset can conquer finance and artificial intelligence, what other massive, chaotic systems in our world are just waiting to be tamed by someone who's willing to ignore all the noise and just get back to first principles? What could you build with a kernel mindset?